Hi everyone, welcome to
amazing channel of Brilliant Qatar.
When you're rubbing one body with another body, electrons are transferred from one object to what? Another object. Okay, this process, this type of electricity is been given a name.
halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Hello, hi, good evening students. I hope I'm audible. Please comment. I can understand you people are there. Please comment. I'm expecting some hearts, some fires in the chat window. And please share this link to your friends, those who are preparing for the board exam. We have in limited days only. So please comment quickly. Yes, I can see Smriti, Sandeep, hi. Yes, Shadow. Hi, good evening. So we don't have time to waste. So without wasting time, we are going to start our discussion. You know that today is February 5th. February 22nd, you are going to start your board exam. So we have 16 days. 17th day, you will be in the exam hall. So you know that in physics, chemistry, maths, biology and all, MCQs are the area where most of the students are losing marks. If analyzing your pre-board, model exams and all, you can see the same thing. So we need to crack more marks, maximum possible marks in MCQs. That's the reason why for the coming 16 days in the evening from 6:45 to 9 p.m. all our brilliant teachers will be there with you to discuss the most probable MCQs. So we have limited time, so we are trying to cover as many questions as possible. We are not saying we will be expecting exactly the same question for the board exam, but my dear students, question will be conceptual. So we are trying to cover all questions which is based on the important concepts. If you are thorough with this concepts, we are sure you will be able to score full marks in MCQ part. 24 MCQs including case study, 24 multiple choice questions are there in physics. That's a very important percentage of the total physics paper. So I'm expecting your kind attention, and when I'm displaying each question, analyze yourself, comment your answer at that moment itself before I'm working out the solution on there, so that you can make an analysis on yourself. So I'm expecting quick response from all of you. So without wasting time, I'm going to the first question. Hi, the Jilani is there, Nandani is there. So Atul, good evening to all of you. So we are going to start. So today in today's session we will be having physics and chemistry. First 1 hour will be physics, then it will be chemistry and physics. We are trying to cover 2 chapters. The first 2 chapters, electric charges and fields and electric potential and capacitance. So I'm going to the discussion now. So these are the chapters that we are going to cover today. Question number 1. Look at this. Work done in carrying a charge Q from A to B along a semicircle is. This is the first question. Work done in carrying a charge Q from A to B. See, the charge Q is at A. We need to move a charge Q from A to B along a semicircle of radius R. What is the work done? So you can comment your answers quickly. Yes, Sanjay, I can see. All of you, please comment your answers quickly. Right, see in electrostatics you can see these many questions of these type. What is the work done? Calculate the work done. So my dear students, if in electrostatics if a question comes based on work done, please don't go with the basic formula for work done, that is force into displacement. It's a very simple concept. The idea that we are using here is work done is equal to change in energy. So here what you need to understand is it's a question from which chapter? Is it from first chapter or second chapter? Is it electric charges on fields or potential? It is from potential. So at the middle you can see there is a plus Q charge, and we need to move another charge Q from A to B. That's what you need to do. Like already some answers are there. Yeah, so I'm just going to the answer. You know that if there is a charge Q, what is the potential formula due to a point charge? At a distance r, we have the potential V is equal to 1 by 4 pi epsilon naught. It's a constant into what? Q by R. This is the formula for potential due to a point charge. I hope all of you remember this formula. So using that formula, if you are calculating what is the potential at the point A, remember this distance is R. So potential at A will be 1 by 4 pi epsilon naught Q by R. Same way, what will be the potential at B? B is also at the same distance. So at B also you can see the potential is same. So potential at A is equal to potential at B in this case. If potential is same, tell me what is the potential difference? Potential difference is 0. If potential difference is 0, what's the work done? Work done will also be 0, because potential difference is the work done in bringing a unit charge. Then there is chance of question, what is the significance of this semicircle of radius R? Simply to confuse you. So if work done question comes, find initial potential, potential at the point, starting point, potential at the ending point, take the difference, and many questions you can see answer as 0. So please read the question carefully. I hope it is clear. So I am going to the next question. So answer for this one is what? 0. 0 is the answer. Potential work done in moving that charge is 0. So I am going to the next question. Right. Question number 2. Look at this. The electric field at a small distance r from an infinitely long plane sheet of charge is directly proportional to. Directly proportional. You can comment your answers. Yes. Nathan, Sanjay, Shini. So I can see many students. Please comment your answers. Quickly share the link to your friends, those who are preparing for the board exam. Yes, Sanjay is saying that it's option D. Let me check, Sanjay. Others also please comment. So what is the question? The electric field at a small distance r from an infinitely long plane sheet of charge is directly proportional to. Gauss theorem applications. We have 3 application students. You know that first one is what? Electric field due to a line charge. Please recall the formula. What is field due to a line charge formula? It is 1 by 2 pi epsilon naught into lambda by r. Second is plane sheet. Formula is sigma by, what is it? Sigma by 2 epsilon naught. Electric field due to, if there is a plane sheet of charge, due to the plane sheet, the electric field at any point is given by E is equal to what? Sigma by 2 epsilon naught. Now what is the question? This field is proportional to what? Options are r square by 2, r by 2, r raised to 4 by 4, then r raised to 0. I hope you got the answer. Yes. See, there is no r in this formula. That means electric field due to a plane sheet of charge is independent of the distance. So independent means here you can see what is the power of r? It's 0. R raised to 0 is 1. So independent of r is, it's option D. Option D is the right answer for this question, Sanjay. Very good. So please, it's not only for this particular question, you have to check the related formulas. Like we have 3 applications of Gauss theorem: line charge, sheet of charge and spherical shell. So please recall all the formulas. Yes. So I'm going to the next question now, question number 3. Look at this. A conducting sphere of radius r is given a charge q. There is a conducting sphere, it is given a charge q. Consider 3 points: B at the surface, A at the center and C at a distance r by 2 from the center. The electric potential at these points are such that, you can start commenting your answers. Electric potential. So please understand the situation. There is a conducting sphere. So it's a conductor sphere. There are 3 points on it. Which are the points? There is point A. Where is the point A? A is at the center. So at the center, we can mark the point A. B at the surface. At the surface, there is point B. And where is C? C is at a distance r by 2, where r is the radius. So if r is the radius, at a distance r by 2, the point C we can mark. Then the question is about the potentials. You can comment your answers. Yes, please, quickly.
1 by 2 pi epsilon naught r by 2 pi epsilon naught into lambda by r. Second is plane sheet. Formula is sigma by 2 epsilon naught r by 2 epsilon naught.
Sanjay is saying it's option A. Others also, please comment quickly. Satvik is also saying it's option A. Let's check, my dear students. This is potential question. Potential. From second chapter, there is an important topic called electrostatic properties of a conductor. What are the electrostatic properties of a conductor? In that, we made a very, very important point. Please note that electric potential inside a conductor is a constant and is equal to the potential on the surface. Inside is a constant and is equal to the potential on the surface. So A, and where is C? C is here. B is on the surface. So everywhere electric potential is what? It is same. So what is the answer for this question? So R is a radius, means here if potential is 5 volt, here also it will be 5 volt, here also it is 5 volt. So potential is same everywhere. Right answer, Ayan. Yes, very good. It's option A. Potential will be the same. But what about if there is a point outside the sphere? Then what will be the answer? If I am marking there is a point D, can we say that the potential is same at D also? The answer is no, because D is outside, means we can use the formula 1 by 4 pi epsilon naught Q by R, inversely proportional to R. So the potential will be decreases as we are going outside. Clear or not? Yes. Okay, right. So all of you please comment, and I'm going to the next question. I'm trying to cover as many questions as possible in this 1 hour. Fourth question. A particle A has a charge Q and particle B has charge plus 4Q. With each of them having the same mass m. When allowed to fall from rest through same electrical potential difference, the ratio of their speeds VA is to VB. Ratio of, it's a bit tricky question, ratio of velocity. Ratio of velocity. So please understand there are two charges, charge A and charge B. B, the magnitude is given as plus Q. And B has a charge of, A is given a charge of plus Q and B is given a charge of what? Plus 4Q. Plus 4Q. With each of them having the same mass. Mass is same. So mass of A is M, mass of B is also what? M. When allowed to fall from rest, please note that point. Initially, both the charges are at rest. Rest through the same electric potential difference. So both the charges are released across same electric potential difference, then the ratio of their speeds VA is to VB. Comment your answers, please. Yes, all of you. Look, what is the concept here? Velocity. How can you relate? Mass is given. If these type of question comes, my dear students, you have to understand, we have to use the idea of energy conservation here. Initially, it is at rest and it is accelerating through a potential. So surely that charge can gain some energy. If a charge Q is accelerating under a potential difference V, what is the formula for energy? Energy is U is equal to QV. All of you know this formula, QV. And when the charge starts moving, because of this potential, that energy will be changed into what? Kinetic energy. So you can equate this with kinetic energy. That means half mv square is equal to qv. This is the formula which we need to use. Now you can apply in these two cases. So first one is VA. So we can write half m into VA square. What is the charge of A? It's Q. So Q into potential is same V. Second one, half m VB square is equal to, the charge is 4Q, potential is again V because it is at the same potential. Now take the ratio, you will get the answer and comment it, please. Yeah, quickly. So if you are dividing it half m, it's cancel, we get VA square y by VB square is equal to QV cancel, we get what? 1 by 4. They are asking what is VA is to VB. So take the square root. VA by VB is equal to what? 1 by 2. 1 is to 2 is the answer. It's option B. Option B is the right answer. How many of you got it? Yeah, Sanjay, very good. Yes. Satvik, yes, correct, Satvik. Okay, so I'm going to the next. Before that, once again, please share our link to all your friends. Let all of them watch this. Okay, so I'm going to the next question now, question number 5. So this is another important concept like energy conservation idea we are using. Question number 5. A dipole is placed in a uniform electric field. Its potential energy will be minimum when the angle between its axis and fields is It's again a conceptual question. Potential of a dipole is minimum potential. Do you remember the idea of stable equilibrium position and unstable equilibrium position and all? That's very important, not only in electrostatics, in magnetism also you can see the same. Comment your answers quickly. Right, let's check. A dipole is placed in a uniform electric field. So there is a uniform electric field of intensity E. Uniform electric field of intensity E. In that electric field, we are going to place a dipole at an angle theta. Tell me what is the formula for its potential. Potential energy U is equal to minus PE cos theta. Please study this formula. Potential energy of a dipole in a uniform electric field formula is minus P cos theta. Now the question is at which angle the potential energy will be minimum. So we can substitute, we can check with the values. If theta is equal to 0, cos 0 is 1. So we get U is equal to what? Minus P. If theta is equal to 0, minus P is the potential. Now theta is equal to 90 degree means we get what? Cos 90. Cos 90 is equal to 0. So U is equal to 0 for theta is equal to 90. Now what about if theta is equal to 180? Cos 180 is minus 1. So minus 1 into minus P you get what? P. So you just compare these three. In which case we are having minimum potential energy. Minimum potential energy is in the first case, isn't it? Minus P. So first case is theta is how much? 0 degree, and that is the case where potential energy is minimum. And my dear students, please note that is energy is minimum. Yes, it is stable, right? So we will call it as what? Stable equilibrium position. So in some question you can see it is at the stable equilibrium position. Means you have to understand theta value is equal to what? 0. So answer for this question is option A. Option A. Yes. Smriti, I hope it is clear for you. Yes. Minimum. So maximum means we can say it is P, that is when theta is equal to 180 degree. So I am going to the next question number 6. Equivalent capacitance of the given circuit is. Direct question based on capacitor, combination of capacitors. You know the formula, isn't it? So in series, what is the formula we have to use? 1 by C series is equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus etc. In parallel, it's C1 plus C2 plus C3. So in this type of question, the only thing you have to understand which of them are in series, which of them are in parallel. So check the connection quickly and answer. All are identical capacitors, you can see. It is given. This is 15 microfarad, this is 15, this is 15, this is also 15. So options are there. There is a cell, leave it. They are not asking any potential or charges. It is just to find the total capacitance. Yes. I can see some answers. Smriti is saying it's option B. Let me check. Others also, please quickly comment the answers. You can see these three are in series, right? These three capacitors are connected in series. Positive plate is connected to negative, positive is connected to negative. There is no other connection in between. So surely we can take those three are in series and they are identical capacitors. So three identical capacitors are connected in series. So I am using the formula 1 by C is equal to 1 by C plus 1 by C plus 1 by C. Identical means all are same. Okay, so we get what? 3 by C. 1 by CS is equal to 3 by C. So CS is equal to what? C by 3. What is C? 15. 15 by 3 is equal to 5. That means the effective capacitance of these three capacitors is what? 5. Is it over? No. Now the effective of those three, that means this is connected in parallel with what? This one. So we already got it as 15 plus there is another 15, right? They are in parallel. In parallel combination, what is the formula? So sorry, here I made a mistake. It is 15 by 3, 5 only. So this is 5 and this is 15. So we get 15 plus 5 is equal to 20. Yeah, right. 20 is the answer. That means option B. Option B is the right answer. Simple question. Don't make mistake in this type of question. Yes, Satvik, Atul, correct answer. Yeah, Smriti also got the right answer. So I'm going to the next question. I hope this is clear. So please practice some questions based on combination of capacitors, series and parallel. Okay, next. A charge Q enclosed within a cube. What is the flux through one of its face? This question I have been discussed for all of you in your class. It's a repeating question. Without doing any calculation itself, I think you can answer this. Quick. A charge Q enclosed within a cube. What is the flux through one of its face? One of its face. Yes, Smriti, right answer. Yeah. See, cube. We can simply use Gauss theorem here, right? If this is a cube, where is a charge? Charge is inside. Charge is inside. Q charge is inside. They're asking what is the flux through one of the phase. You know that in a closed surface. In a closed surface, we can use what? Gauss theorem. So directly use Gauss theorem. So by using Gauss theorem, you can see that what is Gauss theorem formula? Flux, total flux passing through any closed surface is equal to, total flux is equal to 1 by epsilon 0 times the net charge. What is the net charge? Net charge is Q. So this is a total flux. It's not the answer for this question. It is a total flux. They are asking flux through one phase. So you know that a cube has how many phases? There are 6 phases for a cube. So 6 phases are there, which means this is a flux passing through 6 phases of the cube. They are asking only through one phase. So we can simply divide it by 6. So what is the answer? Q by 6 epsilon naught. Q by 6 epsilon naught is the answer. Option A. Option A is the right answer. Very good, Atul. Ayan. Yes, right. I'm going to the next. Question number 8. Electric field intensity. Be careful. Be careful. You can easily answer this, but students don't think that by saying a question it is hard, I can't do this. Please should not have such a feeling. Read it carefully. You can easily answer this. If electric intensity E is along x-axis, then the equipotential surfaces are parallel to. That's a question. Equipotential surfaces are parallel to. So before Satvik is asking, sir, flux through all phases. So surely Satvik, all phases, that the entire cube, if they are asking, it will be Q by epsilon naught only. One phase only we should divide by 6 because there are 6 phases. Clear? Right. So equipotential surface. Do you remember what is equipotential surface? What's the definition? It's a surface at which the potential is the same everywhere. That's called an equipotential surface. What are the properties of an equipotential surface? That's also important. This question is based on one of that property. The work done in moving a charge from one point to another on an equipotential surface is 0. The potential difference between any 2 points on an equipotential is 0. Third point, the most important, equipotential surface is always what? Perpendicular to the electric field. That is the point this question is based. Equipotential surfaces perpendicular to the electric field lines, and some other properties are also there, like equipotential surface will never intersect. Now let's check. If electric field intensity is along x-axis, x-axis means positive x-axis, so let us draw such a coordinate system. See, this is x-axis and positive y-axis is z-axis. X, Y, Z. Okay, what is the direction of electric field given? Electric field is along positive x, so electric field is going this way. This way. So they are asking, then equipotential surface is parallel to. Equipotential surface is parallel to what? If electric field is going in this direction, equipotential surface has to be perpendicular to that. That means this is the equipotential surface. So you have to check the diagram and tell me that particular surface is parallel to which plane. This surface you can draw here or here. So it's same. So that is clearly it is lying in which plane. You can see YZ, that means YOZ plane. That means that surface is parallel to YOZ plane. Is it clear? So which is the option? Yes. Ansar is saying it's option C. Yes, Satvik, right answer. It is option C. Option C is the right answer for this question, YOZ plane. Clear or not? Okay, so important, read the question carefully. You can easily answer this. Don't make silly mistakes. Always you need to double check your answer while doing MCQs. Going to the next question, question number 9. Electric charges plus 10 microcoulomb, plus 5 microcoulomb, minus 2 microcoulomb and plus 8 microcoulomb are placed at the corners of a square of side √2 meter. The potential at the center of the square is a direct numerical. They are asking what is the potential at the center of the square. You know the formula for potential. Potential due to a point charge. What is the formula? Tell me, students. Potential due to a point charge is V is equal to 1 by 4 pi epsilon naught, that is our constant, into Q by R. Q by R. This is the formula where R is the distance. Now what they are asking, there are many charges, like 4 charges are there. In a system, if there are n number of charges, how can you find the total potential? It's simple, sum of potential due to each charge. You know that potential is a scalar quantity, so there is no concern about the direction. Just calculate its magnitude and add them. So we have a square. square. And the charges are kept. So I'm just writing it as Q1, this is Q2, Q3 and Q4. So they're asking what is the net potential at this center. Net potential at this center. So we need to find the potential due to each charges separately and add. Here advantage is there. What is that? Since they are asking potential at this center, this distance will be the same for all the charges. So that means if due to Q1, if you are finding potential here, if this is R, then this is R, this is R, this is R. So distance is same. Yes or no? Now we need to find that distance. For that, it is given side is how much? Root 2. Side of the square is root 2. That means this is root 2. This is also what? Root 2. Can you find the distance? You can find the diagonal of this square using Pythagoras theorem. So the diagonal will be root of what? Root 2 square plus root 2 square, you will get 4. Square root of 4 is 2. 2 is the diagonal. From here to here, the distance is what? 2 meter. Then what will be half of that? It is 1 meter. Now the things become very simple. R value is what? 1 meter. Then what is the formula comes? R is 1 meter, means it's just like 1 by 4 pi epsilon naught Q. Right? Then how can you find the total potential? Total potential V is equal to, we can write it as VA plus VB plus VC plus VD. Add all the potential. So this 1 by 4 pi epsilon naught value, you know that it is 9 into 10 power 9 into what? R is 1 meter. So we can just add the charges. Look, 10 micro we can substitute later. 10, next is 5, then minus 2 plus 8, and micro means 10 power minus 6. All of you please calculate and tell me the answer quickly. Yeah, Smriti is saying it's B. Aditya. Sanjay is saying that it's 1.8 into 10 power 5. 1.8 into 10 power 5, that means option D, Sanjay, right? Yeah. Check please. So this is 9 into 10 power 3 will come here because there is minus 6, and 10 plus 5, 15 minus 2, 13 into 21. Okay, so 21 into 9, 189 into what? 10 power 3, but the options are in terms of like 1.8, so if you're writing it as 1.89 into 10 to the power 5. Yeah, so it's option D. Option D is the right answer. 1.89 into 10 to the power 5. Yes. So I think it's clear. So take your time to do this kind of question. Make sure that you are not making any silly calculation mistake. Okay, going to the next question, number 10. Yes, an electric dipole is placed in a non-uniform electric field. What acts on it? It's again a repeating question. In many question paper, this kind of question comes. So 2 points are there to be noted. What happens to a dipole when it is kept in an electric field? That's the first thing. Then you need to check if it is a uniform electric field, what is the result? In a non-uniform electric field, what is the result? So please note that in a uniform electric field, if you are placing a dipole, we already studied that. We made a derivation also for what? Torque. And in that derivation, hope you remember, we found that the net force acting on the dipole is 0 because they get cancelled. But if it is a non-uniform electric field, my dear students, these dipole will experience both force as well as torque. Please note, if it is a uniform electric field, the answer is only torque. If it is a non-uniform electric field, both force and torque. So which option? Yes, already I'm getting the comments. Both A and B, torque and force, because this is a non-uniform electric field. Non-uniform electric field, it will be experiencing both torque as well as force. Clear question. Right. So please be careful. You need to check the question whether it is a uniform field or a non-uniform field. Question number 11. 2 plates are 1 centimeter apart and the potential difference between the plates is 10 volt. The electric field between the plates. Very easy question. Very easy question. Plates are separated by a distance of 1 centimeter. Potential difference is given as 10 volt. Quickly answer this. They are asking what is the electric field. Just recall the relation between electric field and potential. Relation between electric field and potential, what is it? E is equal to V by D in a uniform field. Non-uniform field only we need to use dV by dr, integration method and all. But here it's in between 2 plates, means it is uniform only. So just calculate and tell me the answer. Yes, Satvik. Yes, Sanjay is saying it is 1000. Yes. Potential value 10 volt. Distance is given in centimeter. So 1 centimeter is 1 into 10 power minus 2 meter. This will go up 1000 Newton per coulomb is the answer. Option C. Option C is the right answer. So please study the formula relation between electric field and potential is equal to V by D. Okay. Yes. So next question. Next one. Question number 12. 3 capacitors of capacity C1, C2, C3 are connected in series. Their total capacity will be. I am expecting the answers from your side, all of you. I need the fire, hearts and all. Afreed. Yeah. What is the answer for this question? All of you comment please. Sathik is saying it's C. Where are the others? Comment. This is, you know the formula, right? You know the formula for combination of capacitors. Yes. Option A for parallel, that's correct. But they are asking series in this case, no? In series, what is the answer? Quick, I am waiting here because I need to see how many of you are making it correct. Okay, Smriti is saying it's C. Ayan is saying it's C. Sathik is sticking on C. Atul is saying C. Are you sure it is C? I didn't get any comment from Sanjay. Okay students, listen here. Series combination, what is the formula? 1 by C series is equal to what? 1 by C1 plus 1 by C2 plus 1 by C3 if 3 capacitors are connected in series. Isn't it? Yes. So here if you are using 1 by C1, 1 by C1 is what? C1 raised to minus 1. 1 by C2 is what? C2 raised to minus 1. 1 by C3 is what? C3 raised to minus 1. Got it? But is it C? Remember, this is not C, this is 1 by C series. That means if you are calculating C series, it has to be 1 divided by C1 raised to minus 1 plus C2 raised to minus 1 plus C3 raised to minus 1. Isn't it? Confusing one. So what is the right answer? Is it option C? It's not option C, my dear students. There is an option. You can see. What is that? None of these. None of these. It is option D. I hope it is clear for all of you. It's a confusing question. Most of the students will be writing this as the answer. Clear or not? Please comment. If it is clear, please comment. So I can go to the next question. Yes, Adul, Sanjay, is it okay or not? I'm going to the next. Question number 13. The mean electric energy density between the plates of a charged capacitor is. Q is a charge on the capacitor, A is the area of the. Question is direct. Mean energy density of a capacitor. Energy density, we have a direct formula. It is half epsilon naught E square. But here you can see the formula is not like that. It is given in a different way. So mean energy density in between the plates of a capacitor is. So to answer this question, not only that final formula, you should have an idea what is this energy density. Energy density means you know that it's energy per unit volume. Energy per unit volume. In a capacitor, you know that we have different formula for energy. So let it be the capacitor. Its plate area is A, distance of separation is D. Then you know that what is the volume of the capacitor? It's A into D. Volume of the capacitor is area into distance, A into D. Okay, now you should divide the energy by that volume. But energy, which formula we need to use? If you are checking the options, you can see in all options there is Q. Q is there, charge is there. Basic formula we studied for the energy of a capacitor is half CV square, but in that formula Q is not there. So it is better to take the formula with Q. So I am taking, we have a formula for energy that is Q square. Q is small letter, so Q square by 2C. Q square by 2C. This formula I am using. Let's check. This divided by volume. So energy density is equal to this by. That means Q square by 2C divided by volume of the capacitor. What is it? A into D. So Q square by 2 into capacitance formula. What is capacitance formula? Epsilon naught A by D. Got it? Divided by what? A into D. So we get multiplied by 1 by AD. So D got cancelled. So the result will be Q square by 2 epsilon naught a square. Check the option. Q square by 2 epsilon naught a square. It is option B. Option B is the right answer. So please study. It is an important topic. Energy stored in a capacitor and energy density. So you should understand what is the meaning of energy density. It is energy per unit volume. Based on the question and the given option, you have to think which formula we have to use for this question. Okay, next question number 14. The angle between electric dipole moment and the electric field strength due to it on the equatorial line is, again a direct question. Dipole moment and electric field on the equatorial line. You know that there are two important derivations for electric field due to a dipole. Remember, what is the first one? It is at a point on axial line. Other one is at a point on equatorial line. Okay, I'm not going to the derivation now, but at least try to recall the formula. On axial line, if this is the dipole, minus Q plus Q. Axial line is here or here, anywhere you can take. And what is the formula? It is 1 by 4 pi epsilon naught 2p by r cube. Yes or no? And what was the direction of that field? It was in the direction of what? Dipole moment. On axial line, the direction of resultant electric field is in the direction of dipole moment, but on equatorial line, where is that equatorial line? Equatorial line is here, and we found that over here there will be one field in this way, one field in this way. Resultant field is like this. Do you remember the derivation? Yeah, resultant field is towards left. Towards left means, remember that dipole moment direction is towards right. Electric field intensity is towards left. On equatorial line, it is towards left. Tell me what is the angle between these two. Easy question only, but clear idea should be there. It is 180 degree. I can see the options. Yes, Ayan, right answer. Sanjay, correct. Yes, Smriti, right answer. It is C. Option C, 180 degree. At the same time, if they are asking it is on the axial line, means the answer will be 0 degree. They are in the same line. Okay, very good. I'm going to the next question number 15. Question number 15. 2 point charges plus 9E and plus E are 16 centimeter away from each other. Where should another charge Q be placed between them so that the charge placed is in equilibrium? So that the charge placed is in equilibrium. Here, what you need to notice, there are two charges. Both are positive charges, isn't it? So let me draw a diagram here. See. There is plus 9E and there is plus E. So both are positive. So both are positive means surely the equilibrium position will be in between, because as per the definition you that for electric field intensity, if you are keeping a unit positive charge here, due to this positive it will be experiencing a repulsive force. Due to this positive also it will be experiencing a repulsive force. So the net field can be 0 or net force can be 0 where? In between. Now they are asking where is that charge? For that, this total distance is given as 16 centimeter. In option you can see both ways options are given. 24 centimeter from 9E, 24 centimeter from plus E, 12 centimeter from plus E, like that. So you can take any point as the point where the force is 0. So I am just marking a point here and assume that point is at a distance R from plus 9E. Let's check whether we are getting the answer in terms of the distance from plus 9E or not. Now what is the condition for equilibrium? Equilibrium means net force is 0. For net force to be 0, the net field should be 0. That means the field due to this plus 9E will be equal to the field due to what? This plus E. You know the formula for field due to a point charge. What is it? 1 by 4 pi epsilon naught Q by R square. So I am just writing the condition for equilibrium is E1 is equal to what? E2. So E1 is 1 by 4 pi epsilon naught Q1. What is Q1? 9E by the distance it is taken as R square. That R only we need to find. Q by 9E by R square. It should be equal to again 1 by 4 pi epsilon naught. What is the other charge? It is E by this distance, the remaining distance. Total distance is taken as how much? 16. This is R, means surely this distance will be what? 16 minus R. So we can write it. It will be 16 minus R the whole square. Okay. Now this 1 by 4 pi epsilon naught cancel. E got cancelled. You can see that 9 by R square is equal to 1 by 16 minus R the whole square. Take the square root. Square root of 9 is 3. So 3 by r will be equal to 1 by 16 minus r. Solve this. 3 into 16 minus r is equal to r. 3 into 16 is 48 minus 3r is equal to r. So we get 4r is equal to 48. We got the answer. R is equal to 12 centimeter. R is equal to 12 centimeter. From where? We have taken in the question is, we have taken it is from plus 9e. So 12 centimeter from plus 9e, that is the answer for this question. 12 centimeter from plus 9e, option B. Yes, correct answer to Sanjay, Ayan. Yeah, Satvik, please check. Yes, I think it's clear for you. I'm going to the equilibrium position, finding the net electric field, finding the net force. Many such question you can see in this. So please practice this kind of question. Okay, question number 16. The equivalent capacitance between A and B. Can you quickly answer this? Equivalent capacitance between A and B. There are 4 capacitors you can see. C, then one more C is there. What is the equivalent capacitance? Just identify which of them are in series, which of them are in parallel, and quickly answer the question. Yes. See, without any doubt you can see that these 3 capacitors are in series because in between nothing is there. Okay, now this capacitor, how can you take? Here we need to find across A and B. So B is here. So if I am redrawing this circuit diagram, I can redraw it like this. All of you, please note. A is here. Then there is one capacitor, second capacitor, third capacitor. Then there is a connection, and that connection capacitor you can mark in anywhere, like on this wire. So I'm just marking the capacitor over here, and that is connected to this point. And where is B? B is coming from, see, this is C, this is C, this is C, this is C. So between the third and fourth only the B connection is going. So this is the third one, this is the fourth one. So between 3 and 4th you can mark what? B. So this is a redrawing diagram. Now the things are very simple. These 3 are in what? Series. Okay, if these 3 are in series, what will be the effective of that? 1 by C equal to 1 by C1 plus 1 by C2. So we get 3 by C by 3. The effective of these 3 will be what? C by 3. And that one and this one are in series. So now things are easy. So we just add in, in parallel. So in parallel combination, what is the formula? C plus C by 3. So we get 3C plus 4C by 3. 4C by 3. How many of you got the answer? It is option D. Yes, Atul, correct answer. Ayan, correct answer. 4C by 3. Option D. D is the right answer. 4C by 3. Okay, right. So I'm going to the next question now. So please practice once again combination questions. Always you have to try. 2 capacitors of equal capacity first connected in parallel and then in series. The ratio of the total capacitors in the 2 cases will be. Check. There are 2 identical capacitors first connected in parallel. So if you are taking C and C are the 2 capacitors. There is one capacitor, there is another capacitor. We are connecting these 2 in parallel. C, C. What is the net capacitance? So I am taking it as C1. So it will be 2C. If 2 identical capacitors are connected in parallel, their net capacity will be 2C. Then in series. So in second case, CC in parallel. Effective capacitance will be what? Parallel combination, series combination formula you can use, we get what? C by 2. If identical capacitors are connected in series, it will be halved. So C by 2. They are asking what is the ratio. So we get C1 by C2. C1 by C2 will be what? 2C by C by 2. What is the answer? 4:1. Yes, how many of you got the answer? Quick. So the answer is 4:1. It's option C. Because first connected in parallel. In parallel, you will get maximum capacity. In series, you get minimum. Yes, yes, Atul, right. 4:2, Atul, it is option C. Yeah, 4:1. Satvik, right answer. Option C, 4:1. Okay, I'm going to the next question number 18. An electric dipole of moment P is lying along a uniform electric field E. The work done in rotating the dipole by 90 degrees. Again, a repeating type question. Work done in rotating it. This question can be asked in different ways also. I'll tell you what are the other way of asking question after explaining this. Here, what is the question? An electric dipole of moment P is lying along a uniform electric field. So initially, that dipole is lying along a uniform electric field. So if this is the electric field, the dipole is lying parallel to this. parallel to this, and they're asking the work done in rotating the dipole by 90 degrees. So from here we need to rotate it by 90 degree. What is the work done for that? We have a formula for work done. W is equal to minus PE into what? Cos theta 2 minus cos theta 1. This formula you can see while deriving the potential energy of a dipole. You can see this equation. I told you in the class, like, we need to mark this equation. It is important. Work done in rotating a dipole. Now what is this theta 1 and theta 2? Theta 1 is the initial angle and theta 2 is the final angle. So here we can substitute it. It is minus P into, what is the final angle? Initial angle, it is along the direction. Along the direction means theta 1 is what? 0 degree. Theta 2 is to 90 degree. Rotate the dipole by 90 degree means by 90. Can you substitute and tell me the answer? So we get cos 90 minus cos 0. Okay, so we get minus P into cos 90 is what? 0 minus cos 0 is 1. So the answer is P. Option A. Option A is the right answer. Yes, Sanjay. Fahad, yes, correct answer. I mean, for the last question it is correct. Yeah, Satvik, option A. Clear or not? Now I told you the other ways of asking question based on this one is, they won't give any angle value in the question. Like here it is along the direction, rotate 90 degree. Instead of asking, they may ask, calculate the work done, to rotate it from its stable equilibrium position to unstable equilibrium position, or unstable equilibrium position to stable equilibrium position. So you should have an idea what is the meaning of the stable. I told you already in one of the questions which we discussed today. Stable means theta value is what? 0. And unstable means theta is 180. Okay, so those idea you should keep it in your mind. Then you can easily solve this kind of question. I think it is clear. I am going to the next question, number 19. Okay, the capacity of a parallel plate condenser is 5 microfarad. When glass plate is placed between the plates of the conductor, its potential becomes 1/8 of the original value. Potential becomes 1/8 of its original value. Then the value of dielectric constant. A bit tricky one. You know that when a dielectric slab is inserted in between the plates of a capacitor, what will happen to its capacity? It will increase, isn't it? We have formula for new capacitance. Do you remember? C is equal to C naught divided by 1 minus T by D into 1 minus 1 by K. This is the formula for the finding the new capacitance. What is K here? K is the dielectric constant and T is the thickness of the dielectric slab. But in this question, they are not saying anything about the thickness, which means it's like when a glass plate is placed between the plates, means what you can take, the entire region in between the plates is filled with what? A dielectric. You know that if the entire space in between the plates is filled with a dielectric, its capacitance will become K times. That means if initial capacitance is C naught, new capacitance will be what? K Z naught. So that idea we can use here. But here it is, the question is if potential becomes 1/8 of the original value. So new potential is 1/8. Then what is the dielectric constant? Okay, so let us take this as the initial capacitor. That means without the dielectric slab, I have a capacitor. Okay, I have a capacitor. Take its capacitance as what? C. Capacitance as C. Let the charge on this base Q and potential as what? V. You know the formula for V. V is equal to what? Q by C. Q by C. Okay, you can take it as the first equation. Now what we are doing, we are inserting a glass of dielectric constant K. So surely capacitance will become C dash, potential will also become another value. So new formula will be V dash by what? Q by C dash. Now what is V dash? It's given 1/8 of initial value, so we can write it as V by 8 equal to Q by C dash is, you know that it become K times, because when a dielectric is inserted, the capacitance becomes K times. Got it? Right. Now what is this Q by C? Q by C is V only, so we get V by 8 is equal to what? V by K. We got the answer. What is K? K is equal to 8. Simple question. K is equal to 8. Okay, yes. Yeah, future doctor. C, correct answer. Right. Okay. Clear? So question based on effect of introducing a dielectric slab in between the plates of a capacitor. Okay, so we are going to the next question now. Next question. Yes, question number 20. An electric dipole consisting of two opposite charges 2 into 10 power minus 6 coulomb, each separated by a distance of 0.03 meter, placed in an electric field of 2 into 10 power 5 Newton per coulomb. The maximum torque, direct question, torque, calculate it quickly and comment your answer. Yes, Fahad, right answer. Do this. Torque. What is the torque formula? Torque is equal to P sine theta. Torque acting on a dipole in a uniform electric field. Tau is equal to P sine theta is the formula. Okay. But here they did not give the value of theta. But do you need that? No. Because in question you can see they are asking maximum torque. You know that for that torque to be maximum, that sine function has to be maximum. Sine function maximum value is 1. So tau max is equal to what? Maximum torque is equal to PE. Now you just substitute what is dipolement equation, Q into 2L, that is dipolement into electric field intensity. Substitute what is Q? 2 charges magnitude, it is 2 into 10 to the power minus 6 into L. Remember students, here there is chance of making mistake by taking 2 and L separately. Remember, 2L is the length of the dipole, it's not L. 2L in the formula, 2L is the length of the dipole. That length is given as 0.03. So don't put 2 into 0.03. 2L represents the length of the dipole. So it is 0.03 into electric field strength. What is it? 2 into 10 to the power 5. 2 into 10 to the power 5. So we get this one as 2 into 2, 4 into 3 into 10 to the power minus, this will be minus 8, minus 3, right? Yeah. So 12 into 10 to the power minus 3, right? 12 into 10 to the power minus 3 is the answer. 12 into 10 to the power minus 3 Newton meter. Option B. Option B is the right answer for this question. A direct question based on the torque formula. Yes. Correct. Sanjay, Hayan. Yeah. I'm going to the next question now. Question number 21. Listen here. The capacity of a parallel plate condenser is 12 picofarad. If the area of both the plates is doubled and the distance between them is reduced to half, the capacity of the condenser. This is again a repeating type. Easy question. Okay. Actually, no need to substitute the values. Directly we can go to the answer. I'm expecting the comments quickly. Yes. Future doctor. Yeah. So area of both the plates is doubled and distance between. So just recall the formula. C is equal to what? Epsilon naught A by D. This is the capacitance formula, right? Now new capacitance. What is happening here? Epsilon naught into plate area is doubled. Area of the plate is doubled, 2A. Distance is reduced to half, so D by 2. So this 2 will go, we get 4 epsilon naught A by D, isn't it? 4 epsilon naught A by D. That means you can see the capacitance becomes 4 times. Capacitance becomes 4 times. So what is the initial capacitance? 12. 12 into 4, 48 picofarad. Option B is the right answer. Option B, 48 picofarad is the right answer. Yes. Fahad, right answer, correct. Yeah. Okay, Ruben, yes, correct answer, right. Happy to see you guys. Now I'm going to the next question number 22. A metallic shell has a point charge Q kept inside its cavity. Which one of the following diagrams correctly represents the electric lines of force? I am expecting your comment. I am not going to explain this. Please comment. Which is the right answer? Which is the correct diagram for this question? A, B, C or D? Yes, Ruben is saying it's C. Sanjay is saying it's C. There is an unknown student. Okay, anyway, he's also saying it is C. All are saying it's C. C is the right answer. Correct, because you know that it's a metallic shell. Metallic shell means it's a conductor. Electric field inside a conductor is 0. So here you can see field, then there is conductor, though no field, and it is coming out. Okay, right. So that's a logic we can apply here for metallic conductor. And if two diagrams identical to this comes, means we need to use another logic also. That means the field lines are always perpendicular to the surface of a conductor. That also you should remember. Okay, right. Very good, very good. I'm going to the next question, number 23. 23. Right. The minimum electrostatic force between two charged particles placed at a distance of 1 meter is. The minimum electrostatic force between two charged particles placed at a distance of 1 meter is. Question is direct. Electrostatic force only they are asking. So you know that in electrostatic force we have to use Coulomb's law. So F is equal to 1 by 4 pi epsilon 0, which is 9 into 10 to the power 9 into Q1 Q2 by R square. This is the formula for electrostatic force. Now R is given as 1 meter. So substituting R as 1 meter, we get Q into 9 into 10 to the power 9 into what? Q1 Q2. Now the question here is the charges are not given. Then how can we find the force? Can anybody tell me how can we go ahead? The charge is not there, then how can you find? Remember students, they are asking what is the minimum electrostatic force. For the force to be minimum, charge has to be minimum. What is the minimum value of charge? Quantization principle, basic charge is charge of electron, which is 1.6 into 10 to the power minus 19. It is not possible to make a charge with magnitude less than that. So you just substitute Q1 as 1.6 into 10 power minus 19, Q2 also is 1 power 9. That means 9 into 10 to the power 9 into 1.6 into 10 to the power minus 19 into 1.6 into 10 power minus 19. That means it is all square. So we get 9 into 10 to the power 9. 1.6 square will be 16 square is 256, so we get 2.56 into 10 to the power minus 38. So just multiply this 2.56 into 9. Approximate answer, because you know 2.56 into 10 will be 25 point something, so slightly less than that, there is 23. So the answer will be 2.3 into 10 to the power minus 28 Newton is the answer for this question. Clear or not? Yes. How many of you got the answer for this? A charge of electron. Sanjay, very good. Yes, assume it to be Akshit. Very good, very good. Yeah. So the right answer is option A. Option A is the right answer for this question. Right. So 23, question number 23. I'm going to question number 24. Look, a parallel plate capacitor has two layers of dielectrics as shown in figure. This capacitor is connected across a battery, then the ratio of potential difference across the dielectrics is. Potential difference across the dielectrics means potential difference across the capacitors. So you know that if you are inserting two dielectric slabs like this, this combination, this arrangement will be behaving like two capacitors connected in series. So you can think this is first capacitor C1, this is the other capacitor C2. C1 and C2 are connected in series. Then we need to find the ratio of potential difference. So if V1 is the potential difference across this one and V2 across this two, we need to find V1 by V2. See, since they are in series, charge will be same. So charge on this capacitor is Q, here also what? Q. Then what is the formula for V? V is equal to Q by C. Then we need to find V1 by V2. V1 by V2 will be Q by C1 by what? Q by C2, which is equal to C2 by C1. You can substitute the value and can you comment your answers? C2 means second capacitor. So there is a dielectric. Dielectric constant is 6. So capacitance will become 6 times 6 epsilon naught A by, look at the distance. Distance for that one is 2D. So the formula is epsilon naught A by D only, but since there is distance 2D, so we need to take it like that. Divided by, what is C1? C1, the dielectric constant is 2. And epsilon naught A by, what is the distance? Only D. So, can you tell me the answer? Yes, Sanjay, right answer. Akshat, right answer. The answer will be 3 by 2 because 2, 6 will be cancelled. 3 by 2. 3 by 2. Okay. So please don't skip this type of question by thinking that it's very hard. It's a simple concept. You can easily solve this. Right. So we have only 2 minutes remaining. By 7:45, I will be ending the physics session. Exactly by 8 o'clock, the chemistry session will be starting. So I'm going to the last question of this session. Okay. 2 point charges are placed at a distance r. In air experiences a certain force, then the distance at which they will experience the same force in a medium of dielectric constant K is. So new distance only we need to find, force is same. So F is equal to, you know that in air what is the formula? 1 by 4 pi epsilon naught Q1 Q2 by R square. Now F dash is 1 by 4 pi epsilon naught epsilon R. Okay. So dielectric constant is K into Q1 Q2 by, we need to find new distance, that I am taking R dash, so R dash square. Okay, so these are the two forces, like in air this is a formula, in a medium this is the formula. Okay, now it is given that it is experiencing the same force, so you can just equate these two. F is equal to F dash, so many terms will be cancelled. 1 by 4 pi epsilon naught Q1 Q2 will be cancelled, so we get 1 by R square is equal to 1 by K R dash square. Okay, so we need to find R dash value only. So look at this, K R dash square is equal to R square. So R dash square is equal to R square by K. We need to find R dash value, take square root, we get R by root K. R by root K. That is option C. Yes, option C. Right, very good. So within this 1 hour, we have discussed 25 questions. I hope you got some idea. So my dear students, once again please be focused on the concepts in physics, because there are plenty of MCQs. We cannot limit our discussion into 100 questions or 500 questions. The scope is very, very high. So be thorough with the concept, be thorough with the idea, then you can solve all the questions from this. So we will be continuing this session till 20th of this month, till February 20th. If you are not getting time to watch the live session, at least whenever you are getting free time, go through this recorded video and check, practice these type of question. Okay, so by this I am going to wind up the physics session. We'll be coming back with the next topic, current electricity, the remaining chapters, all the chapters will be discussed. Thank you for watching. Thank you for being with us. Stay tuned. Thank you.
Hi dear students, welcome to Brilliant Qatar and welcome to the 16 days MCQ challenge. I think physics session already completed. Now we are moving to the chemistry session. We have the chapters Haloalkanes and Haloarenes and Biomolecule. These two chapters MCQ we are going to discuss today. Before that, let me just check it how many other those students who are present in the online, can you please come in the chat box dear all? Can you please come in the chat box? Okay. Yes, okay. So I think you are seriously preparing for your examination, Sanjay. Adul, future the one doctor is there. Okay, let's hope for the best. And Adul, okay, good evening all of you, very warm good evening all of you. Here we are going to begin the battle for your board examination, which is going to happen 20th and 7th hour examination, chemistry examination. At any cost we have to score good marks in that one. There is no compromise. I hope you all are seriously preparing for your board examination. So there is no chance, there is no give back here in this examination, because this is a career deciding examination dear all. This is the exam which is decide your career. So we are not wasting your time. Good evening all of you. Good evening Satvik, Ruben, some other names also all are there. Okay, yes. So our purpose is not to just discuss few questions and finish the session dear all. It is a serious session. At the same time you should be with us with a strong spirit. We also will be there with you with this 1 hour. So 1 hour, I'm not wasting your time. So in this session we are going to discuss these two chapters, in which Haloalkanes and Haloarene Biomolecule. I hope you know entire theory part very well. Am I right? Whether you studied the Haloalkane, Haloarene Biomolecule chapter thoroughly or not. Can you please come in the chat box all of you? Can you please come in the chat box all of you? Have you studied these two chapters thoroughly or not? Well, how many of you are confident in these chapters? And my aim is not to just discuss some question. Again, I'm repeating. Here we want to discuss lot of question we have to discuss. At the same time, we have to discuss the complete theory also. So it should not be a wastage of time. Okay. Now I'm going to start the first question from the 2023 board exam, what they would ask from haloalkane. Okay, 2023 previous year, your seniors, what they wrote, what they faced in their 2023 board examination paper from haloalkane chapter, that I'm going to show you. I won't say the answer immediately. You tell me what is the answer, because it's a 1 mark question. Okay, so haloalkane, haloarene, this is the 2023 board question. Can you tell me dear all, what is the answer of this question? Then only I will start the session. Tell me, what is the answer of this question? Read it carefully. Which of the following belongs to the class of vinyl halide? Vinyl halide. What is the answer for this question? 2023 board exam paper, they were asked this question, and what is the answer of this question? How many of you? How many of you can able to answer this question? Tell me dear all. Show your spirit, show your answers, show your confidence. I'm getting 3 answers now. B, B, B. I think all are supposed to answer B. Let me check it all of you. Which of the following belongs to the class of vinyl halide? Yes dear all, it is option B, no doubt. It is option B, no doubt, because the compound is given CH2 double bond CBr, then we have one CH3. This is the compound. You know very well how to check it, whether it is allyl, vinyl, benzyl, alkyl, aryl, everything, right? So here this is the halogen. This halogen connected carbon is sp2, yes, and is this the nearest carbon also sp2. Yes, we studied if the halogen connected carbon sp2, again it's sp2 in a chain, what we call it as vinyl, right? Vinyl. So option B is the correct answer dear all. So this is the 2023 board question they were asked in haloalkane. Let me show you another 2023 board question from Biomolecules. biomolecule chapter. All of you carefully note it. Say simple question from the biomolecule. Those who are preparing biology and all, biomolecule not at all a difficult topic. Even chemistry, it's a simple thing. Tell me dear all, what is the answer of this question? Proteins are polymers of what? Proteins are polymers of what? Proteins are made up of what? Proteins are made up of what? Yes, all are giving that. Satik, Sanjay, Adul, G, Faraz, all are giving that answer. That is option B. Option B, amino acid, right? Amino acid. Yes, dear all, correct one. Proteins are polymers of, proteins are made up of what? Many number of amino acid. Amino acid general formula RCHNH2COOH. Can I ask you one more question? As I told you dear all, be online. Be online. I want to discuss many things with you. So first thing, my question, whether amino acids are, so answer is ready, amino acid no doubt, but my question is this one, amino acids are which one? Whether alpha amino acid, beta amino acid, gamma amino acid, delta amino acid. Can you comment in the chat box, all of you? Whether amino acids are made up of, or the proteins are made up of which type of amino acid, whether it is alpha, beta, gamma or delta. Come on all of you, can you tell me which type of amino acids, which type of amino acid are used to prepare protein? Can you tell me? Can you tell me? Sanjay already given the answer, that is alpha. I'm expecting each one of you the correct answer dear all. There is no second chance. There is no second chance. This is the final area that will decide your career. So please keep in mind all of you. So this is the career deciding exam. That seriousness should be there, and all the theory what all you things you studied in this 2 year, especially in this 12th year, you are going to write in a paper within this 3 hour. At the time, all these data should come to your mind at a point. So that is answer is what? Answer is what? Alpha amino acids. Correct one dear all. It's made up of what? Alpha amino acids. Yes. Proteins are made up of alpha. Why I specified this question here means this is a JEE question. This is a JEE question. Even for the same type of question you can expect for your board exam. So answer is, let's go with amino acid. Dear all, let's go for the another 2023 board exam question is here. Retention of configuration is observed in which configuration? Come on. Come on all of you, the retention of configuration is observed in which configuration? You may study it, retention of configuration, inversion of configuration, racemization, something like that in SN1 and SN2 mechanism. Can you comment all of you? Can you comment all of you? Which one? Retention. Retention of configuration is observed in which one? Yes. SN1 reaction. Yes. Thank you all of you. Let's show the power. At the same time, the team spirit, the every attachment, all of them, keep it with you, keep it with us, and we can crack this JEE, NEET or whatever the examination which is upcoming days. Let's crack it very well. Yes, that is SN1 mechanism. Let's go with the first one. Yes or no? So what do we study? Retention of configuration is SN1. That is inversion of configuration is SN2. There is a racemization that is also in SN1. Yes, that's a point we study. Yes, dear all, let's go to the next question. What is the correct order of reactivity of haloalkane toward beta elimination reaction? You know what is beta elimination? Treating a haloalkane with the alcoholic KOH form alkene. This is called the beta elimination reaction, right? So in beta elimination reaction, we are going to study what is the reactivity order of haloalkane. What is the reactivity order, dear all? The first step, whatever the haloalkane, suppose I am taking the tert-butyl chloride. So what is the first step in the beta elimination? Removal of halogen, formation of carbocation. So that's beta elimination is nothing but it's just asking you which carbocation undergo what? Stabilization. You know that which carbocation is more stable. That's it. That is tertiary greater than, secondary greater than, primary. I think we can go with option B. Let me check it. How many of them answered? How many of them answered? I think B, that is a correct answer. Dear all, I can't able to understand what is your name. But anyway, good. Good, very good. That G something is mentioned there. If you mention your complete name means it is favor for me. I can discuss your name detail. Okay, so Sanjay, that is B. Yes, it's B, dear all. So note the point. Beta elimination is based on the stability of the carbocation form, that is tertiary greater than, secondary greater than, primary is the correct answer. My dear students, whether the answer is correct or not a factor here. Please write your answer here. Make the correction yourself. Not at all worry, oh my answer is wrong, I made a silly mistakes here. No problem. That mistake you will remember and don't repeat in the main examination. That's it. Okay, let's go to the next question, dear all. How many beta carbon atom does 2-bromobutane have? A simple question. How many beta carbon atom does 2-bromobutane? What is 2-bromobutane? That is CH3, CHBr, CH2, CH3. I think within second you may get the answer, dear all. That is, this is 2-bromobutane. How many beta carbons are there? How many beta carbons are there? Come on all, how many beta carbons are there? Yes, that is C2, right? 2 beta carbon. You know, halogen connected carbon is called alpha. Alpha nearest carbons what we call beta. Yes, there are 2 beta. There are 2 beta carbon atom. Yes, let's go with option C. Adul, Ayan, already given the answer. Ruben, yes, correct. Yes, dear all. So hope you all are ready. And keep doing this one, dear all. Keep doing this one. Whenever we show a question, immediately your mind should go to that page, collect the topic, apply here, get the answer, put it in the chat box. Okay, let's go for the next one. What is formed when ethyl magnesium bromide react with the water? Ethyl, you know, ethyl C2H5, ethyl magnesium bromide, what happen if it react with the water? You studied that, very good. It's a Grignard reagent. It is a Grignard reagent. You know very well. Grignard reagent react with the water. What happen? You know, water contain 2 ion, H plus and OH minus. And here the ions are Mg plus and alkyl minus. So the alkyl minus combined with H plus, C2H5 with H plus, you will get C2H6. What is C2H6? C2H6 is ethane. C2H6 is what? Ethane. Correct, all of you. You already studied that. The Grignard reagent, that's a reasoning question you can expect here all. Why Grignard reagent kept in anhydrous medium? You know, Grignard reagent is highly reactive one, so it react with the water, form alkane. Okay, so what is the point? Grignard reagent react with the water, form what? Alkane, that is nothing but ethane. I think this answer is clear, that is option B. My dear students, I can see the support in the chat box. I hope you are getting, I hope you can able to follow me. Am I right? Am I right? Can you follow me? Can you follow me? Because I'm not wasting your time. I need to practice. I need to discuss lots of questions today. 50-60 questions we have to discuss this within this 1 hour. I think all are okay. Can you support in the chat box, all of you? Can you comment in the chat box? I can't see you. I can't see you. I can't hear you. I can able to understand. You are there only with your messages. Okay. All right. Okay. Thank you. Let's go for the next one. What will be the product of the following reaction? Isopropyl bromide with the sodium in dry ether. You know what is isopropyl bromide? Dear all. You know, isopropyl bromide is CH3, CH3, Cl. This is what isopropyl chloride when react with the sodium in dry ether. You know, it is our, yes, Woods reaction. This is our Woods reaction. Through this, what can you prepare or what is the main product? Can you comment? Can you comment here all? Which options? That isopropyl bromide on reaction with the sodium in dry ether, what it can produce? What can produce by this reaction? I think one answer I am getting, Ayan is given, that's option D. That is G is given D, and Sanjay, it's option D. Yes, dear all, option D is the correct answer. Option D. Why it is option D? You know, in Wood's reaction, alkyl group get doubled. Yes, this is our alkyl group. Just write a copy of this one. You will get CH3, CH3, single bond CH, CH3, one more CH3. Yes, what is this? 2,3 dimethyl butane. Yes, correct answer is what? Option D. Very good, all of you. Keep going, keep going, keep going, and remember all these points until 27th this month. Okay, this all point should be there in your mind. Okay, next question. Let's go. Compared to haloalkane, the reactivity of haloarene towards nucleophilic substitution reaction is, come on, a direct question. You compare haloalkanes and haloarene, they asking you the reactivity of haloarene towards nucleophilic substitution, whether it is less, whether it is high, whether it is very high, whether it is equal. Let's go with option. No doubt, I think, my dear students, you may already studied very well. That is what? Option A, right? Option A, very low, right? Low. We studied haloarene, halogen connected to benzene ring. There is a partial double bond formation due to the resonance. So what happened? It's very harder to remove the halogen. Then only we can substitute a nucleophile. Yes or no? So haloarenes are less reactive toward nucleophilic substitution reaction than what? Haloalkane. Please don't forget, all of you. Yes, that is answer is option A. Students already given the correct answer. Very good. Keep going, all of you. Next one, good question. Which of the following compound is most readily converted to phenol when heated with the aqueous NaOH solution? You may study this. All are, you see, all of you, chlorobenzene, right? All are chlorobenzene. You may study chlorobenzene on dose process, right? Chlorobenzene on dose process, you will get phenol. What is dose process? Treating with aqueous NaOH, then acidification, right? So here, which will undergo this phenol formation faster? All having chlorobenzene. So, but which one? Which one undergo this reaction faster? Chlorobenzene is there, 4-chloronitrobenzene is there, 2,4-dinitrochlorobenzene is there, 2,4,6-trinitrochlorobenzene is there. All of them contain chlorobenzene. So which chlorobenzene undergo dose process faster? Can you say? Can you say? That's one answer I am getting, one answer I am getting, two answers I am getting. That is option D. Option D is the correct answer. Option D. Why? Because it is 2,4,6. What it is? 2,4,6 trinitro. 2,4,6-trinitrochlorobenzene. Dear all, these all are what? Withdrawing group. You know, these all are what? Minus I effect electron withdrawing group. If they are electron withdrawing group, they will withdraw the electron from carbon and chlorine and make the carbon chlorine bond what? Weak. You can easily remove the chlorine, make the nucleophilic substitution faster. So electron withdrawing group, if there on this haloarene, it make the nucleophilic substitution faster. So answer is option D is the correct answer. Okay. Temperature, pressure, condition. Yes, what is given in NCERT, it is compulsory to know. We know in dose process 623 Kelvin, 300 atm pressure, everything is important. Okay, dear all, everything is important. Okay, yeah, fine. Okay, thank you all. Let's go for the next one. What is the major product formed when chlorobenzene react with the nitric acid in concentrated sulfuric acid? It's a simple question. Don't make mistake. All of you comment your answer in the chat box. Come on. Come on everyone, what is the major product formed when chlorobenzene react with, what is actually the reaction? You know, chlorobenzene when react with concentrated HNO3 and concentrated H2SO4, you know, it is our nitration. You will get chlorine and nitro here as a major product, right? So what is the major product? You know, para is the major product. They're just asking what is the IUPAC name. Can you say what is the IUPAC? Maybe students write their reaction, everything perfect, but the compound should be, name of the compound should be, we should be serious about that. What is it, dear all? Here chlorine and nitro, dear all, chlorine and nitro both are very least priority group. Anyway, we will write chlorine first. Yes or no? Anyway, we will write chlorine first. So we will say that 1, 2, 3, 4. What is the name? 1 chloro, 4 nitro, benzene. 1 chloro, 4 nitro, benzene. Yes, answer is which one? Answer is which one? Option. Answer is which one, dear all? Yes, option D. So when we answering one question, our concentration should be on that. Okay, you may think, sir, I want to answer, I have to answer 4-mark question, 5-mark question, all are waiting for me. Yes, it's there with you, but 3 hour is there. Okay, don't lose, because it's a do-die questions. MCQ question means because of silly mistake and frustration, don't make any problem in that MCQ, dear all. Be confident on that question. Be ready to answer that question. Be ready to mark that question until we getting 1 marks. Okay, so let me go for the next one. Predict the minor product. Very careful. Predict the minor. Predict the minor product formed when chlorobenzene react with. Predict the minor product formed when chlorobenzene react with chloromethane. What is chloromethane? CH3Cl with anhydrous AlCl3. I think you got the answer. I think some of you maybe memorize that. Yes, it is Friedel-Crafts alkylation. Yes, it is Friedel-Crafts alkylation. Tell me all, what is the product here? Minor. They are asking you the minor, okay? Minor. They are asking. Be careful about this one. Say the, I think most of them already joined. Abu, Ayan, Krish, say the, yes, Sanjay Ji, Ayan. Okay, let's see. See, this is alkyl group, where it goes. You know, chlorine, halogens are ortho para directing group. So alkyl group can go to ortho and para. You will get 2 products, but which is minor? The ortho one, right? The ortho one is the minor product. So this is the minor product. What is the IUPAC name, dear all? What it is said to be? That is, we can call it as, okay, we can, it's, I think it's mentioned in ortho meta and all. What we can call it as orthochlorotoluene. Orthochlorotoluene. Yeah, Karthikeya, Manjunath, all are ready, right? Abu, what is the answer? What is the answer? Is it metachlorotoluene or orthochlorotoluene? What is the answer here all? They are asking the minor product, okay? Minor is which one? It will give you actually ortho and para. Among that, which is minor? Ortho is the minor. Careful. Ortho is the minor. Very good, Satik. Ortho is the minor. So let's go with option C. Orthochlorotoluene is the minor product. Here we have the next question. On oxidation from the chapter Biomolecule, I think no need of much explanation. All of you comment your answer in the chat box. On oxidation with a mild oxidizing agent like a bromine water, what glucose gives? Those 5 reactions we studied in glucose, those all reaction, dear all, is a must question for your exam. Tell me, glucose on reaction with the bromine water, what it form? Yes, glucose on reaction with the bromine water, it will give you gluconic acid, and in presence of something, you will get saccaric acid. Can you say, dear all, what is this something? Glucose when react with something, you will get saccaric acid. Can you tell me what is that forming? So here answer is option C, no doubt, gluconic acid. But which one? Something will give you saccaric acid. Which one? Yes, I hope you remember that. Very good. That is concentrated HNO3. Concentrated HNO3. Very good. You know, it's a mild oxidation and it's the strong oxidation. Clear, dear all? Yes, right? Okay, Manjunath, Ji, Abu, Satik, yes, all are given the correct answer. Yes. Yeah, iodine gives normal hexane. Yes, iodine give normal hexane. What it shows that glucose, all 6 carbon are in a straight chain. Yes, dear all, very good. Next one, invert sugar is, come on dear all, what is the answer? Biomolecule, another question. Invert sugar is, which option can be matched? Which option can be matched? This is just a beginning. Lot of questions are waiting for you. Invert sugar is which one? You studied invert sugar, sucrose. Sucrose is called invert sugar. Sucrose is called invert sugar because it contains what dextro and levo is there. Yes or no? Yes. So what is the answer can be suggested here? Yes, Anjums. Okay, fine. Okay, what is the answer, dear all? What is the answer? Very good, very good. That is option D. Mixture of glucose and fructose in equimolar quantity. Right? The mixture of glucose and fructose. You know, invert sugar. The invert sugar you studied in biomolecule chapter is sucrose. Sucrose contain what? Glucose and fructose, right? Glucose and fructose. Yes, they are the sucrose molecule, and that is called what? Invert sugar. Yes, option D is the correct answer. Okay, no problem. Don't worry. Keep doing, keep doing, keep doing. Next question, one another. Glycosidic linkage is an. Come on, dear all. What is the quick answer? Biomolecule quick answer. Biomolecule quick answer. Adul, cane sugar we take from sucrose. Yeah, sucrose is what? Nothing but cane sugar. That contain what? Glucose and fructose. Glycosidic linkage is a, dear all, don't make mistake, don't make mistake. We studied what? Glycosidic linkage. We studied another one, peptide linkage. We studied phosphodiester linkage, right? Phosphodiester linkage. What is their bonding? Glycosidic linkage is a type of ether linkage. Ether linkage, you can able to see them O connection, ether linkage. Peptide linkage is a type of what? Amide linkage. Amide, you can able to see what? NHCO connection. That is amide linkage. And what about phosphodiester? It is a ester. See, phosphodiester ester linkage, you can able to see COO connection. So dear all, glycosidic linkage is an ether linkage. That is option C is the correct answer. Ether linkage. Yes. So dear all, these 3 points all of you memorize. Glycosidic ether linkage, peptide is amide linkage, and phosphodiester is which one? Ester linkage. Yes, my dear students, are you ready? Are you ready, or are you confident? Are you confident in these topics and all? Are you confident in these chapters, in these topics and all? Yes, right? Okay, yes. So all of you, can you just make a fire in the group? Can you just activate the group by putting a fire? Everyone, don't sleep. Okay, don't sleep. These 2-3 weeks we should not make a not to take a little more rest and all. It is not the time to make take a rest here. It's a complete platform. We have to do our best in the examination. Thank you, all of you. I hope you are seriously preparing. I can able to see those students who are seriously preparing. Yes, they are there, and they are keep rocking in the examination. Dear all, there is no other way. There is no other shortcut. Hard work on it and practice the question, through which you can able to revise the chapter also. Just 2 hours spend it, that complete chapter we can revise it. Next question, which reagent is used to convert glucose into saccharic acid? Already I told you that it is nitric acid. You have an answer, I think. Yes, dear all, glucose when react with concentrated HNO3 nitric acid, it will give you what? Saccharic acid. That is nothing but option B is the correct answer. Yes, next go for the next question. Now this question you should answer. You should answer this question. Carbohydrates are stored in our human body as the polysaccharide. Which one? Which one? Yes, very good. Keep going. Carbohydrates are stored in human body as the polysaccharide. Or let me give you one more hint, which is present in our brain, liver and muscles. Where it is or which one it is. Dear all, carbohydrates are stored in our human body is called what? Glycogen. Yes, glycogen is also called what? Animal starch. Glycogen is also called what, dear all? Animal starch. Yes, option B is the correct answer. Yes. Okay, next one. Which one of the amino acid can be synthesized in our body? You may study there are 2 type of amino acid, essential amino acid and non-essential amino acid, right? Essential amino acid and non-essential amino acid, non-essential. What do you mean by essential, dear all? Essential amino acids are not synthesized in our body. It's only getting through food. And what about non-essential amino acid? It's already synthesized in our body. Not need to take it external. So what are the example for essential? At least we should remember some example, dear all. That is a non-essential amino acid. You may studied which one? Glycine, right? Glycine and alanine. Glycine and alanine and all you may studied in non-essential amino acid. And which is a which of the following amino acid can be synthesized in the body? Means they're asking which is a non-essential amino acid. Glycine, alanine, these all are what? Non-essential amino acid. It's already synthesized in our body. Yes, I think Gayatri already given the answer. That Ponnambalam already given the answer. That is which one? Sanjay already given the answer. That is what? Alanine. They're all alanine. Glycine, alanine are non-essential. Valine, leucine, these all are what? Essential. So at least so here we have to compulsory to know. Even for theory exam they ask you what is essential amino acid, non-essential amino acid, acidic, basic, neutral and fibrous protein, globular protein, difference example, everything should be there with you perfectly. Okay, next question. Which of the following gives positive Felling's solution test? Actually Felling's test we are studying in aldehyde chapter, but Felling's test we are discussing in our carbohydrate area, reducing sugars and non-reducing sugar. Dear all, they are asking which one of the following gives Felling's test, means which is a reducing sugar. You know, reducing sugar which can reduce Felling's and tolerance reagent, which is a Felling's, which is a one give a Felling's test, dear all. I think now number of answerings are increasing. Number of answers are increasing. Those who are already hidden their face, I think I can able to see that their answers are giving in the answer. It's something, someone, most of them I think are going with the option glucose. Very good. Dear all, you may studied all monosaccharides are reducing sugar, right? Glucose is a monosaccharide. You know, only one non-reducing sugar we studied, that is which one? Sucrose. So here let's go with option which one? Option C, glucose is the correct answer. It is a reducing sugar. It will reduce Felling's and tolerance reagent. Yes, dear all, good. Next question. The two functional group present in a typical carbohydrate are? The two functional group present in a typical carbohydrate are? What are the two functional group which is commonly present in any carbohydrate? Which one? Which one? Which one? Which one? Don't make mistake. Don't make mistake. Don't make mistake. Be careful. Be careful. Be careful. The two functional group present in a typical carbohydrates are. Let me draw. You say your answer there. Okay. I will draw glucose and fructose structure here. You know that is a glucose structure and CH2OH, OHH, OHH, HOH, OHH, and we have CHO, right? Aldehyde. This is glucose structure, and you know fructose, how to draw it? CH2OH, then we have OHH, OHH, HOH, then we have C double bond O, then we have CH2OH. These, both of these are carbohydrate. My question, what is common in them? Common in them, there is a chance to make mistake here. I can able to see that mistake in that option, but not very. Please correct that mistake. Okay, dear all, it's not option C. It's not option C. You know, this is a this is glucose, this is fructose. You know, both are carbohydrate. This contain aldehyde, this contain alcohol, but this contain ketone and this contain alcohol. So what is common? Alcohol is common. Yes, alcohol is common. Fine, but the other one is what? CO group. It can be aldehyde or ketone. Okay, so it's not only always not always which one? Aldehyde. It can be alcohol is fixed, but aldehyde or ketone. So what is that meaning? Carbonyl group. So OH and CHO. OH and which one? CHO is not correct. OH and CO, option B. The CO can be aldehyde or ketone. I think many are given correct answer, but no problem. Those who made mistake, dear all, try to please correct it. Okay, next question. Glucose react with acetic anhydride. Come on. Come on, dear all. Come on, dear all. How many times we discussed this question in class? Glucose react with the acetic anhydride. What it form? Glucose when react with acetic anhydride, it form glucose pentaacetate. Yes, option C, right? Glucose pentaacetate formed by all of you. Please write the reaction and study. They will ask you write the reaction when glucose react with this acetic anhydride and all. Okay, please study all those reactions. Next one. Which of the following is a disaccharide? You know, monosaccharides are glucose, fructose, right? Glucose, fructose, ribose and all. And which all are disaccharide? Which of the following is a disaccharide? Simple question. Come on, quick. Which of the following is a disaccharide? Yes, let me go with option A, lactose. Here all, which all are the three disaccharide we studied in this chapter? Sucrose, maltose and lactose. Which all are the polysaccharide we studied? Starch, cellulose and glycogen. Yes, okay, good. Next one. Which of the following is most reactive toward SN1 reaction? Let's go our haloalkane chapter. Come on, dear all. Which will undergo SN1 reaction faster? You know, SN1 reactivity order, tertiary greater than, secondary greater than primary, and check it about benzyl allyl, some groups are present or not. Come on all of you. Which one? Which of the following is a most reactive toward SN1 reaction? Which will undergo SN1 reaction faster? Come on, which will undergo SN1 reaction faster? First one is given as chlorobenzene. Second one is given as a vinyl chloride, right? Vinyl chloride. The other one is given Cl, CH2, CH double bond, CH2. It's an allyl one. And the other one CH3, CH double bond, CHCl. Dear all, you know, first step in SN1 mechanism is the removal of halogen, formation of carbocation, right? Removal of halogen, formation of carbocation. This is the first step in. Your duty to understand which is most stable carbocation. Dear all, this is phenyl carbocation, unstable, cut. This is vinyl carbocation, unstable, cut. This is our allyl carbocation. It is stable due to what? Resonance, right? It is stable due to, this is our allyl carbocation, stable due to resonance. Here it is what? Double bond and positive charge on same carbon, unstable. So dear all, I am going with the option C. How many of them answer option C? Option C, dear all, because option C is allyl, option B is vinyl. Allyl carbocation is more stable than vinyl carbocation. Okay, please careful about it. Next one, can you read the question and answer is, what is the main difference between carbon halogen bond of haloalkane and haloarene? You know, haloalkane, this is the one, and haloarene, this is the one. Tell me what is the basic difference between haloalkane and haloarene. Read it. I'm just leaving now. All of you read the option carefully. What is the correct answer? What is the basic difference between carbon halogen bond of haloalkane and haloarene? I'm going to the answer. All of you check it carefully. The correct answer we can give it as option B, because in haloalkane carbon attached to this carbon attached to halogen is which one? sp3 hybridized, but in haloarene halogen connected carbon is what? sp2 hybridized. This is the basic difference between which one? Haloalkane and haloarene. Okay, no problem. Okay, dear all, whether I told you, no, this is a live discussion. This is not a class, this is a live discussion. You may make mistake, okay, no problem. But for the main examination, my only one kind advice is that main examination, please don't do this mistake. Okay, so be active, be confident. Let's go to the next. Which of the following is a primary halide? Come on, dear all. I'm just going to draw the shape. Okay, you tell me. Those who know the answer, comment in the chat box. Which of the following is a primary halide? Isopropyl. You know, isopropyl is this one. Isopropyl iodide. Okay, isopropyl iodide is this one. It's check it. And secondary butyl chloride. What is secondary butyl? You know, secondary butyl. This is secondary butyl and iodide. And option C is tertibutyl. Okay, tertibutyl iodide is there. And option D is neohexyl. What is neohexyl? Right, 5, 6 neohexyl chloride. Which one is a primary haloalkane? Which one, dear all? Which one is a primary? Dear all, here the halogen connected carbon directly connected to 2 carbon is secondary. Here the halogen connected carbon directly connected to 2 carbon secondary. Here the halogen connected carbon directly connected to 3 carbon tertiary. But here the halogen connected carbon directly connected to 1 carbon. This is the primary. Yes, I am going with option D. Neohexyl alcohol is the correct answer. Good, all of you. Good. I can see that many of you are seriously preparing for your board exam. I hope you can able to recollect what all you studied in the previous classes. Let me go for the next question. Aryl halide. You know aryl halide, for example, chlorobenzene. Aryl halide are less reactive toward nucleophilic substitution as compared to haloalkane due to what? You know two reasons. Why haloarenes are less reactive toward which one? Nucleophilic substitution. Nucleophilic substitution reaction. What is the reason for that one? What is the reason? I'm waiting for your answer. You know that why the halogen removal and nucleophile substitution is harder in haloarene because of two reasons. I'm getting option A, one of the answer. Option B also. Dear all, I think the best correct answer is which one? Option B. Resonance stabilization in aryl halide. You know, due to resonance, they form a partial double bond. Partial double bond makes strong bond. It's very harder to remove the halogen. You may study one more reason, that is because of sp2 character. Higher the s character, higher the electronegativity of the carbon, removal of halogen is again harder. So these are the two reasons why haloarenes are less reactive toward nucleophilic substitution reaction. Correct answer is which one, dear all? B is the correct. What about option A? Formation of less stable carbonium ion in aryl halide. No, that is not the reason. The double bond is the main reason. Partial double bond character. Okay, that is because of resonance. Next question, you know the answer very well. Para-dichlorobenzene has higher melting point than ortho and meta isomer. Why? What is the reason? Para-dichlorobenzene has higher melting point than ortho and meta isomer. That is because of what? Very good. Answer is option B. Para isomer has high symmetry. Para isomers have high symmetry, so they can fix in the crystal lattice tightly. Therefore, they having highest which one? Melting point. Melting point order you may studied. POM. P-O-M. Right. Para, ortho, then meta is the order of which one? Melting point. Very good, all of you. I think next question. Chlorobenzene on reaction with NaOH. This is a direct question. Should not make mistake. I discussed this reaction before. Chlorobenzene on reaction with NaOH at 300 Kelvin followed by acidic hydrolysis produces what? Chlorobenzene react with aqueous NaOH followed by acid hydrolysis. What it give? Phenol. Yes, phenol. Can you please name the name of the reaction first? Can you please name the reaction of this equation? What is that? Which reaction is this? Chlorobenzene converted to phenol, what we call? Dose process, right? Dose process. Yes, it is the correct answer. Very good. Next question. Which of the following is most reactive toward aqueous NaOH? Here I need, okay, very good. Here I need your answer. Which of the following is most reactive toward aqueous NaOH? What is this reaction actually meaning? Dear all, aqueous mean it is SN1 mechanism. aqueous medium. See, SN1 mechanism, they ask you different way, okay, which will undergo SN1 faster, which will give you solvolysis, right? Solvolysis faster, which will give hydrolysis faster, which will give racemic mixture. All of these indicate which will undergo SN1 faster. So which will undergo SN1 faster? Very simple. Cut the remove the halogen, make the carbocation. Halogen plus halogen remove plus halogen remove plus halogen remove plus. Which carbocation? This is just a phenyl carbocation, unstable. But option B, dear all, option B, very careful. Option B is what? Benzyl carbocation. You know, benzyl carbocation is more stable due to resonance. Benzyl carbocation is more stable due to resonance. And this is phenyl. It's also phenyl. Yes, answer is B. Correct answer is what? Option B, dear all, because benzyl carbocation is there. It is more stable due to resonance. So, dear all, SN1 mechanism, if they ask you, first step, remove the halogen, make the carbocation. Dear all, phenyl. Which one phenyl? This is phenyl. Okay. Phenyl is unstable. Next, vinyl. Vinyl is unstable. Okay. Which all are stable one? You know, tertiary, benzyl, allyl, these all are the most stable one. Okay, so just to check it. Lot of questions are there. Let's go very fast. What is the IUPAC name of this compound, dear all? What is the IUPAC? IUPAC related one question we can expect. I'm just expanding. What is this meaning indicate? CCH3. So there are 3 CH3 group and Cl. This is the one. So let us take the longest chain. 1, 2, 3, 1, 2, 3, any one. So 1, 2, 3. There is 2 chloro, 2 methyl propane. 2 chloro, 2 methyl propane. I think we have the answer B. Dear all, when I am showing one new question before my explanation, you should give the answer. That's what we need. When we giving a question, quickly you have to read the question and you have to give a correct answer. That's what we need. I hope you get this question. Yes, next one, dear all, I think now we completed around 31 question. Okay, 31 question now we completed. We are going for the next session. How many structural isomers are possible for a compound with a molecular formula C3H7Cl? C3H7Cl. How many structural isomers are possible? 3 carbon. Okay, 3 carbon. 3 carbon mean I can draw like this one. With 1 chlorine. This is 1 chloropropane. What is the only one remaining chance? Put chlorine on the second position. You will get CH3, CHCl, CH3, 2 chloropropane. I don't think one another structure is possible with this one. So 1 chloropropane and 2 chloropropane. These are the 2 structure possible for this formula. That is, let's go with option A. Option A is the correct answer. Good all of you, good all of you. Next question. What is the IUPAC name of this compound? You should give answer very fast, okay? CH3, CH2, CBr, double bond, CH single bond, Cl. Come on dear all, come on dear all. What is the IUPAC name? Come on dear all. What is the IUPAC name? Q. What is the IUPAC name of this compound? Jilani, it's already given. That's option A. G, A. Okay, Abu. Option B. Okay, just to try all of you. Just try all of you once again. See, double bond having more priority, dear all. Double bond having more priority than halogen. That's the first thing, okay? So, number 1, number 2, number 3, number 4. Bromine and chlorine, if it come alphabetical order, no doubt, bromine should come first. Where is bromine? Second. 2 bromo is a starting. 2 bromo, that is only option A. 2 bromo, 1 chloro, butene. Yes, dear all, very good. Answer is option A. Yes, dear all. Satvik Abu. Yes, good. Next question. Which of the following halide is secondary? Which of the following halide is secondary? I'm going fast this structure. Okay, before that you tell me the answer all of you. Isobutyl. This is isobutyl chloride, and option C N-propyl chloride, and option D is N-butyl chloride. Tell me dear all, which one is a secondary? Which one is a secondary? A simple question, but the main thing we have to know what is this groups and all, isobutyl, isopropyl, tetrabutyl, this all compound we have to know. So which is a secondary? I think this is the secondary because the halogen connected carbon directly connected to 2 carbon. Yes, there is nothing but option A. Yes, Satvik, Jilani, Rees, Sanjay, Adul, Satvik, all are given the correct answer. Dear all, keep going. Next one, which of the following will have the maximum dipole moment? It's a twisted question. Those who are reading NCERT thoroughly, they can able to answer. There is something a difference in this question, something a tricky question. Which of the following will have the maximum dipole moment? We studied all of them having same structure. This is CH3F, CH3Cl, then we have a CH3Br, then we have a Ci, right? Okay, we are expecting, dipole moment nu is equal to Q into R. Dipole moment is equal to charge into distance of separation. You studied fluorine, chlorine, bromine, iodine. When we consider fluorine is most electronegative, fluorine charge is more, so we are expecting this one having greatest dipole moment. But something is clearly, those who are reading NCERT textbook, you can able to say, dear all, which one? CH3Cl is the correct answer because fluorine charge is high, Q is high, but chlorine radius also, when you consider its distance, CCl bond is longer. CCl bond is what? Due to electron repulsion, CCl bond is longer, so its R value is greater. So first CH3Cl will come. So order of dipole moment is CH3Cl, CH3F, CH3Br, then CH3 what? I is the one. So read the NCERT textbook, dear all, thoroughly. CH3Cl having greatest one. CH3Cl having the greatest one. So careful, there is a small, as per normal case we will say this is the highest one, but carefully, dear all, when all of these three given, the highest one is for CH3Cl because CCl bond is longer, so R value greater, so overall dipole moment is greater. Please careful. Next question, force gene is a common name for many time these type of question we were discussing in class. Force gene, it is a poisonous gas produced from chloroform. Its formula is COCl2. COCl2, I can write it as COCl2. COCl2, what is the other name? This is also called what? Carbonyl chloride. This group what we call carbonyl chloride. Yes, option D is the correct answer. Carbonyl chloride is another name of force gene. Let's go. In the preparation of chlorobenzene from aniline, the most suitable reagent is, come on. In the preparation of chlorobenzene from aniline, which is the best reagent? Come on. My dear students, don't take rest. In the preparation of chlorobenzene from aniline, the most suitable reagent is, don't make mistake. Yes, very good. Option C, nitrous acid. You may study what? HNO2, right? Nitrous acid diazotization followed by what? Sandmeyer's reaction, Cu2Cl2, Sandmeyer or Getterman. That is option C is the correct answer. Next question, in which of the following conversion phosphorus pentachloride where PCl5 is using? You know what is the purpose of PCl5? In which reaction PCl5 is using? Can you tell me? In which reaction PCl5 is using? Come on, Jay, very good. Yeah, correct. In which reaction PCl5 is using? Come on, dear all. Which of the following? Mushfiq, Satvik, Adul, Jai, all are given. That is option B. Yes, PCl5 purpose is what? To convert alcohol to what? Halogen. Yes, let's go with option B is the correct answer. I think option B, right? Yes. Okay, yes, good. Next one. Which of the following molecule is chiral? In nature? Chiral mean carbon, all 4 valencies are connected to 4 different group. Which one is chiral? I think some one student I can notice that name is G. Can you please tell your complete name, dear? What's your complete name? I think the answers are which of the following molecule is chiral in nature? Yes, most of the students are saying that is 2, option A, that is 2-bromobutane. Yes, dear all, CH3, CHBr, then CH2, CH3. This is 2-bromobutane. Here the halogen connected carbon is connected to 4 different groups. Yes, this carbon is what? Chiral in nature. Yes, let's go with the option A is the correct answer. Arjun? Good, good, good. Very good. Okay, very good, all of you. Keep going. So answer is option A. Next one. Come on, all of you. Biomolecule again we are entering. Biomolecule again we are entering. Quick answers. Nucleic acids are the polymers of. Come on. Nucleic acids are made up of what? Nucleic acids. They are all only 5 minutes left. Only 5 minutes left. Maximum question. Nucleic acids are the polymers of which one? Nucleotide. Nucleotide. Many nucleotides are connected through phosphodiester linkage. We are getting which one? Nucleic acid. That is option 2. Next one. Which of the following statement is not true about glucose? Come on, all of you. Which of the following statement is not true about glucose? It is an aldohexose. Yes. On heating HI, it forms normal hexane. Yes. It is present in furanose form. I don't think. Yes. You know, glucose is present in what? Pyranose ring. Fructose is present in furanose ring. Option 3 is the incorrect one. That is our correct answer. Yes, dear all? Yeah, correct. Next one. Come on. What is the statement corresponds to? Question number 41. Question number 41. Come on. What is this statement corresponds to? The sequence of amino acid is said to be, what is the name of the structure? Yes. Students are giving correct answer. Primary structure of protein. Yes. You know the specific and sequential arrangement of amino acid in a protein chain, what we call it as, that is our primary structure of protein. Option A is the correct answer. Next question. 1 second. This questions and all 1 second. DNA, RNA contain 4 bases. Which of the following base is not present in RNA? Which is not present in RNA? Come on, quick. Thymine. You know, thymine is present in DNA, instead uracil, which one? Present in RNA. Yes, dear all, Arjun, okay, Ayan. Yes, already given the answer. Next one. Butane nitrile can be prepared by heating. Again, haloalkane. Butane nitrile. What is butane nitrile? CH3, CH2, CH2, CN. Butane nitrile you can prepare from which reaction? Butane nitrile we can, careful. Here there is a chance to make a small mistake. Butane nitrile can be prepared by heating with, you studied how we prepare cyanide, right, from haloalkane. Yeah, that is option D, Chris. Option D is correct one. What is propyl? Propyl is CH3, CH2, CH2Cl. You know, when we treated with the KCN, KCl go, you'll get CH3, CH2, CN. Yes. So answer is which one? Option D. Okay, option D. Yeah, be very serious, very careful. Okay, dear all, last moment. Which of the following reaction does not takes place? Come on, fast. Which of the following reaction does not takes place? You know, the ambidendate, ligands, nucleophiles, KCN will give you cyanide, AgCN will give you isocyanide. Which one is wrong? Good answer. It is option D. Haloalkane when react with the KCN, we will get cyanide, not isocyanide. Option D is the incorrect statement is given, right? Yes. Option D is the correct one. Next one. Which of the following chlorohydrocarbon readily undergoes solvolysis? I told you, solvolysis, hydrolysis, these all are what? These all are SN1 mechanism. Check it all off. SN1 mechanism mean remove halogen, carbocation. Remove halogen, carbocation. Carbocation. Check. Which carbocation is more stable? First one is vinyl, unstable. Second is phenyl, unstable. This is primary, unstable. This is benzyl. Dear all, option C. Option C is benzyl. Yes, Abu. Option B, benzyl carbocation is there with the most stability. It will undergo reaction faster. Other three are least stable. Next one, SN1 reaction faster in. Come on, quick. SN1 reaction faster in. SN1 reaction faster in, faster in. Remove the halogen, carbocation, 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 carbocation. This is primary, this is secondary, this is tertiary, this is again secondary. You know, tertiary carbocation is more stable. Already answers are there, Manjuna, Sanjay, Chris, all are giving that option. C is the correct one. Yes, it is tertiary. Next one, identify the product X and Y in the given reaction. Come on all, identify X and Y in the given reaction. This is a haloalkane with a magnesium and dry ether. You know, it will form Grignard reagent. We will get CH3, CH, Mg, Br along with the CH3. When you treat it with a D2O, D2O is called a heavy water. It contains D plus and OD minus. So, you know, this is the ion Mg plus and this minus. To this minus, D plus will come. You will get CH3, CH, D and then CH3. Yes, where it is. First one, Grignard reagent formation on water it form alkane. Where it is, where it is, where it is. Where it is, dear all, where it is. I think it is option B. Option B, right? Manjunath given the correct answer. Option B is the correct answer. Good, good, good all of you. Good all of you. We have only few seconds with us. Let's go. Chlorobenzene on treatment with the sodium in dry ether give diphenyl. What is the name of the reaction? Chlorobenzene, simple question. Chlorobenzene react with the sodium in dry ether form diphenyl. What is the name of the reaction? What is the name of the reaction? That is called Fittig reaction. You know, Fittig reaction is the reaction between two haloarene. Next one, what is the end product in the following sequence of reaction? Same question, but they given in different way. Tell me, what is the end product Q in the reaction? Benzene on chlorination, you will get chlorobenzene. Chlorobenzene on reaction with the sodium and ether, what you will get? You will get biphenyl. Yes, that is option C. Very good. Option C. Let's go for the last one, 50th question. Maltose is made up of what? 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 You know, maltose is made up of 2-alpha-D glucose. Maltose is made up of what? 2-alpha-D glucose unit. Dear all, study carefully what are the monosaccharide in each. For you, I am giving you few more questions. Which of the following represent a peptide chain? Come on. Which of the following gives a peptide chain? You know, peptide chain mean they should contain repeated CONH bond, amide linkage. Where it is? Which of the following represent peptide chain? These type of questions expecting in this year. Which of the following represent peptide chain? Come on, come on. I'm taking additional 2-3 minutes, all of you. That's for you. So B, give the answer. Everyone, Mushfiq, Sanjay, I think different answers are there. Let me tell you the answer, dear all. I think the answer is C, because you can able to see CONH connection, it should come alternate, right? So here you see CONH is there, but there is a gap and only NH is there, then CO is here. No, a correct order that alternate, this group should come, amide linkage should come. That is option C is the correct answer. Next one, most common type of secondary structure of proteins are, come on. Which are the two most common secondary structure of protein? Which all? Most common secondary structure of proteins are alpha helix and beta pleated. Alpha helix and beta pleated sheet like a structure, right? Yes, next question. Match the following. Yes, it's a sure question for your exam. It's a sure question for your exam. Vitamin, their deficiency questions here all. Come on. Vitamin B1. You studied, no? Vitamin B1 causes what? Beriberi. Vitamin B2 causes what? Chelosis. Vitamin B12 causes pernicious anemia. Vitamin B6 causes convulsion. Overall option A with the third one. That is only one option. D. My dear student, it is a sure question for your exam. Vitamin deficiency. Vitamin deficiency is a sure question for your exam. Be careful. Next one. Bases common to RNA and DNA are. Which all are the bases common to DNA and RNA? Can you tell me? The bases which is common to RNA and DNA are, which all are common? A, G, C. Adenine, guanine and cytosine. Adenine, guanine and cytosine are common. Yes, it's correct answer, option A. And match the column 1 with the column 2. That is nucleoside. You know, nucleoside mean a pento sugar with a base. Nucleotide mean sugar, base and phosphoric acid. DNA contain what? Thymine. So this is C, and RNA contain uracil, that is D. So A with the third one, again that is option A. My dear students, I think you are doing your best. Yes, okay, thank you. I'm going for the last question. It is for you. If one strand of DNA has the sequence ATGCTTGA, what is the complementary strand? You know that if it is adenine, it's bonded to thymine. If it is guanine, it's bonded to cytosine. Yes, I'm taking the species here. All of you, adenine means thymine, T means A, G means C, then C, G, T, A, C, then T. Where it is, dear all? T, A, C, G, A, C, T. Let me show. Yes, option D is the correct answer. Very good, dear all. Very good. I'm sure. You can able to answer all kind of MCQs. So stay tuned. Around 16 days. The most precious 16 days we are going to come with a lot of chapter. Within 2 hours, I think within 2 hours you can make a quick revision about all those equations and points, right? So thank you all, and all of you do your best and show a good result to your parents, to your teachers through your hard work. So dedicate yourself and prepare your maximum potential. We will be there with you. In this upcoming days for complete spirit. At any cost, I told you in the beginning, at any cost we have to score a good mark in this 12th examination, because this is your career, all of you. So thank you so much, all of you. Thank you so much, and good night all of you. Okay, bye.